Hi everyone. Um, Welcome to the help session 1 of the course E220. Today we are going to solve some problems. Here is the problem number 1. Here we have to determine the current flowing through each element and if the charges are given. So first of all, let's start by reviewing some basic concepts. What is electric current? Electric current is the rate of flow of charge. And mathematically, we can express electric current as rate of flow of charge, dq by dt. Here, both current I and charge Q are function of time. And let's review some of the rules of derivatives. This first rule, that is the derivative of a constant term is equal to 0. And the derivative of t to the power n with respect to time is given by n t to the power n minus 1. And derivative of exponent term e to the power at with respect to time equals to e to the power at, and it will be multiplied by the coefficient of time. Now let's start with the first problem. Here, Qt equals to 3t plus 8 millicoulomb, and we have to take the derivative of both the terms, d, derivative of 3t and derivative of 8. The derivative of the second term, this constant term will be equal to 0. So we have to only compute the derivative of this first term. We can take 3 common here. So finally it will result dt by dt. So derivative of t with respect to time, we can use this formula. Here we can see that if the value of n is equal to 1, then the result will be 1 t to the power 1 minus 1. That is t to the power 0, which will be equal to 1. So the final result will be 1. We can even think of dt by dt as if they are canceling out each other. So only 3 will remain. So the answer is current equals to 3 milliampere. We have to take care of this. We have to be very careful about these units. If charge is in millicoulomb, then current will also be milliampere. Now for second problem, now we can see that the first term is we have to take the derivative of 8t square, and for second term we have to take derivative of 4t and derivative of 2. For this constant term, its derivative will be 0, and for this term 4 will be common, and derivative of t with respect to time will be equal to 1. So for this, from the second term we'll get 4. From this first term, t to the power 2, we have to use this formula. If n equals to 2, then we'll get 2 t to the power 1, right? So 2 will be multiplied by 8, and then we'll get 16 t plus 4 ampere. In the third case, we're given exponent term. So we have to use this past formula for derivatives. Here we can see that the exponent, in the exponent term, the coefficient of t is equals to minus 1. So minus 1 will come outside and multiply with 3. Here, this minus 2 will multiply 5. So the final result will be 3 times minus 1 e to the power minus 1. And here, minus 5. And this coefficient of t will be here, minus 2 and e to the power minus 2. So after simplification, we'll get this. Here also we have to be careful that our the units, here the unit is nanoampere. It's nanoampere because the unit of charge is nanocoulomb here. Now let's start the second problem. Here we have to find the power observed or consumed by each circuit element shown in the figure. So first of all, here we will review sign convention. Let's see this figure. Here we can see that this the case of load is given here. So if the case of load is given, we have to understand that inside this element, the current will always flow from positive terminal, positive polarity to the negative polarity. So if the current flows from positive polarity to the negative polarity inside the load, then the power will be positive. So it means that this circuit element is absorbing or consuming power, and power will be given by product of current and voltage. Now let's review the sign convention in case of source. In case of source, if we are considering inside the source, then the current will flow from negative terminal to positive terminal. Or it can also be said as, we can also say that in case of source, the current will come out of the positive terminal and go into the negative terminal if we consider outside the source. But if we can see inside the source, then we can see that the sign convention, current flows from negative terminal to positive terminal. In this case, we say that the source is supplying the power. So the power supplied here is a product of current and voltage. So based on this sign convention, we can solve the given problems. Here, first of all, we will try to solve these two problems. Let's see in this first figure, the current 4 ampere is flowing from positive terminal to negative terminal, right? And the voltage drop is 10 volt. So this circuit element must be lower, right? Since current is flowing from positive polarity to the negative polarity as shown in this first figure. So similar to this first figure. So we can say that this circuit element is absorbing or consuming power. So the power absorbed equals to 4 times 10, which will be 40 watts. And in the second case, current is flowing from negative to positive terminal, right? Inside the element, if you see the inside the element, current is flowing from negative to positive terminal. It's similar to this second case. Current was flowing from negative to positive terminal, and the magnitude of current was 2 ampere, and the voltage drop was 12 volt. So here, this circuit element is a source, so it's supplying the power. So power supplied equals to 2 into 12, which equals to minus 24. So if we say this in terms of power consumed or power absorbed, in that case, this value will be negative. So we can also say it in terms of power absorbed, it will be minus 24. So let's see the third problem. We're given this element. So first of all, we can read this in terms of like this. These both are same. So here what we did is we simply change the direction of current. So when you change the direction of current, its sign will also be reversed. So now we can analyze this. If we analyze this circuit, we can see that current is flowing from positive terminal to the negative terminal. So this is a load. That means it is consuming the power. So here power absorbed or consumed equals to 3 into 5 equals to 15 watts. Thank you for watching this video. I'll see you in the next help session. Thank you.